All right, 3.4, proofs with perpendicular lines. So for this one, I'm not going to write anything down, just please listen. It says if you fold a piece of paper in half twice, okay, and label the points as seen to the right, tell me about A, B, and C, D. Well, if we fold it in half and in half again, then AB is going to be perpendicular to CD, okay? Because the line CD is parallel to the edge of the paper, right? AB is parallel to the edge of the paper, top and bottom. So since you have right edges, right corners on the paper, you fold in half twice, you're getting right angles all over the place. So they are perpendicular. And then AO and OB are going to be equal because O is the midpoint because you fold it in half twice. Okay, find the distance from A to BD. Now remember, this is very important. When you're doing distance, okay, you must do the distance to the line where there's a perpendicular angle. Okay, that was the drawing. So from point A, we could go to D, C, or B. Okay, those all get us to the line BD. But distance, okay, is where the right angle is. And we talked about this previously when we talked about finding the area of a triangle that was graphed. And we had to find this distance, which was perpendicular because that was the height. So AC is the height of this triangle. All right. So if we wanted to find the area of this triangle, we would use AC, BD, multiply them, and divide them by 2. Right now, we're just going to find the distance of AC. Okay? So remember, I suggest you start off by doing this and then put your numbers in. And remember, if you need to, it's X, Y, X, Y. Sorry, X, X, Y, Y on this. X minus X and Y minus Y. All right? So, if it helps here, label XY and XY. So I'm going to do A first. So -3 minus, it's a +1. We're good to go. And then for Y, it's a +3 minus a -1. Be careful. That's why we write the formula ahead of time. Because this is going to turn into +1. All right? So what we have here is the square root of -3 minus 1. So you borrow $3, you borrow another dollar, you owe $4. Not going to matter because we're squaring it. 3 plus 1 is 4 also, squared. 4 squared and -4 squared are the same number, 16. Be careful. If your calculator tells you -16, you got to be smarter than your calculator. So this is 16 plus 16, which is the square root of 32. All right? That is actually the exact answer, okay? Leaving it as square root of 32 is fine, or you could do the square root of 32 and get an actual number, which is approximately 5.7 units. Okay? Moving on. So just more vocabulary. Linear pair perpendicular theorem. So we know a linear pair are two angles that are touching that form a straight line. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Okay, so if two lines intersect to form a linear pair of congruent angles, meaning these are both the same, 1 and 2 are the same, the only way to split 180 evenly is 90 and 90. Okay? So if both those angles are equal, you have perpendicular lines. Perpendicular transversal theorem. In a plane, if a transversal, this is our transversal right here, is perpendicular to one of the lines that's parallel, it's also going to be perpendicular to that line. It just kind of travels on down. The same way we talked about before corresponding angles. Basically, these two right angles are corresponding angles. They just happen to be 90. All right, linear perpendicular to transversal theorem. In a plane, if two lines are perpendicular to the same line, then they're parallel to each other. This is just kind of like the reverse of what we just talked about. All right, use a diagram to prove that J is perpendicular to K. Okay, so we know J is perpendicular to H, right? So now we need to prove that J is perpendicular to K. And I apologize, something happened with the notes. The given was not given to you, so here it is. H is parallel to K, and J is perpendicular to H. Those are both given. Okay, so now we got to go from here and see what we're going to do. Okay, so we know the measure of angle 2 is 90 degrees. Okay, and that's a definition of perpendicular lines. Okay, because since this is 90 right here, if we know they're perpendicular right here and here, then that has to be 90. Now we know, like I just said previously, measure of angle 2 is the same as measure of angle 6. And that's because of corresponding angles. All right, then therefore, the measure of angle 6 is 90 degrees. And that's a transitive property. Okay, we said 2 is 90, 2 is equal to 6, so we can say 6 is 90. And therefore, now we can say what we were trying to prove, J is perpendicular to K. Again, definition of perpendicular lines. All right, the photo shows the layout of a neighborhood. Determine which lines, if any, must be parallel in the diagram and explain your reasoning. All right, so it's hard to see in here, but if you notice right in here, we have a right angle mark. We have a right angle mark here and a right angle mark there. Those three. Okay, so by looking at this picture, we know that P and Q are perpendicular to S. Okay, that's our first thing that we know. So therefore, we know that P is parallel to Q. We also know S and T are perpendicular to Q. And therefore, we know that S is parallel to T. So a lot of stuff we can get from this little drawing, just having a few right angle marks. And that is it.